Hello, everyone. I'm Bart Massey. Welcome once again to Introduction to Programming. Today, we're going to talk a little bit about the thing we call strings, which are representations of text. This is a frustrating topic for me because, like everything else in computer science, there's a lot you need to know about it, and you need to know a lot of it before you can do anything else. But everything in computer science wants to come first. So my compromise is today to talk about a few of the basics, a few of the introductory things about strings, and we will save more stuff for the next time that we talk about them. So there's a lot of ideas on this page. I don't expect you to suck them all in, but we'll at least try to get some of the basic ones. Symbols, text, characters, words, alphabets. There's so many things in here. So what's a symbol? A symbol is some representation that has a meaning. So symbols bind representations to meanings in which way that a variable binds a name to a value. That sounds super abstract, and it is super abstract. We can have whole courses in philosophy and even fancy things called semiotics if we really want to get into what symbols are, but maybe it's best to just take an example. This thing is the heart symbol. Now notice that it doesn't look anything like a heart if you've ever seen pictures of an actual heart, and not so much, right? This looks like something completely different. There's a whole long complicated history here that you can look up. The other thing to think about is that, this doesn't mean typically the organ in your chest or in an animal's chest. It isn't talking about literal hearts, right? It's got a symbolic meaning. It means something vaguely like love and affection, warmth, whatever. And there again, it's not super obvious. There's a long history behind why the idea of the heart is the organ of love. And so there's a lot of abstraction here. But what we're going to concentrate on today is not the meaning at all. We're going to talk about the symbol itself. We think of this thing, this heart, as what we call a character. A character is just a symbol that is representable sort of atomically. It's a single little symbol that has a particular meaning. Words are also symbols. Let's see. Words are also symbols. So, and when we think of combinations of words and other kinds of characters, we call that a text a lot of times. A text is, some collection of words and other characters that has meaning. So a character sort of is one-to-one with some kind of picture. If you look at the letter A in this sentence, it's a picture that we draw whenever we want the letter A. So it represents the letter A in some sense. So the letters of the alphabet are symbols, are characters. Digits of numbers are characters. Punctuation characters exist. If you're in Chinese, sort of whole words or big pieces of words could be a single character. The emoji like this heart are characters, etc., etc., etc. We use a thing called Unicode in computing these days. This is a fairly new thing. It's 20, 30 years old. Which is trying to be a common definition in a single place of every character in the world. Anything you could possibly think of as a character, Unicode has a name for it, has a symbol for it, talks a little bit about what it might mean, and that is a standard that's an ongoing effort. There's also sort of some invisible symbols. We'll talk about those in a bit. So once you understand that words are made up of characters, texts are made up of words and other symbols, these quotation marks are a character, the colon is a character, the heart's a character. Is this bullet a character? Maybe, maybe not. There's a fine line between characters and typography. Then we can think about, well, computers don't just work with numbers, they work with texts. And so we're going to want to have some representation of texts for inside the computer. And in a programming language like Python, what we have are these things called strings, which themselves have a long history, that sort of represent sequences of characters. That is, a string has a first character and a second character and a third character and so forth. And if I string a bunch of characters together into a text, I can represent it in Python as a string. And just in the same way that you've been told in math classes that this character, this thing with the loop and the hooks, is not really the number 5, it's also, but the 5's an abstract concept. Similarly, a string is some symbol that represents some abstract text. But the difference between abstract and concrete gets weird here. We're going to write string values in Python by surrounding the text with matched single or double quotes. So this is an example of a string. This is another example of a string. Notice that the quotes don't match here. I start with a single quote, double quote, and end with a single quote. So this thing is not actually a string. And it's important to notice that string values are just values like any other kind of value. They can be stored in variables just like any other kind of variable. You can sort of do anything with them you can do with a Python value. So if we look at if we start up Python and we say, well, is this a string? Hello world. Yes, it is. And notice that Python chooses to use different quotes than we did. Python likes the single quotes. I like the double quotes, whatever. The point is that's just a value. Just like if I type 5, it echoes 5 back. If I type hello, it echoes the string hello back. That's a string. And like I say, you can put these in variables if you want to. If I store hello in a variable x, well, it's in there. If I say x, sure enough, there's a hello in there. So these are just ordinary values. There's nothing too special about them. Okay, there's some special cases. So first of all, there's a bunch of operators and functions that operate on strings, and there's no way I'm going to describe all of it today, but some basics. Plus can be used between two strings, and if you put plus between two strings, it joins them together. So if I type, if I successfully type x, remember, contains hello. If I type s plus x, then what I'll get is a hello joined to another hello. This is a new string, a new value. Just like if I say 5 plus 3, I get a new value 8. When I say x plus x, I get a new value hello hello that I produced by joining two hellos. There's nothing special there. X plus world, with quotes, is hello world. And there's relational operators, just like there is in numbers. And here it sort of is dictionary order-ish. I say ish because it's really a dictionary with very simple rules by default. Dictionary ordering gets complicated when you consider multiple languages and that sort of thing. But for our purposes, for simple English stuff, the dictionary order thing kind of makes sense. So for example, if I say, is ABC less than AB, it'll be false because in dictionary order, AB would come before ABC. If I say ABC is less than ABD, absolutely, because in dictionary order, ABC would come before ABD. Things get really weird even when there's things like upper and lower case. If I say FOP is less than FOP, well, or equals FOP, those certainly aren't the same from the computer's point of view, and so it'll say false, even though those characters denote the same word. Well, which one's less? That's true. So apparently uppercase letters come before lowercase letters in the dictionary order. Okay, fine. So the point is that basic relational stuff works just like it does with numbers. It turns out there's a repetition operator. If I want 20 highs, I can say hi times 20, or for that matter, 20 times hi. and that combination, multiplying a string by a number, produces that many copies of the string by an integer. If I want to say 20.5 times high, that doesn't probably make sense, and so I'll get an error. It's like, nah, you can really only replicate strings by giving an integer number of times to do it. What if I say 20 times or 0 times high? Then I get what's called the empty string, a string with no characters in it, which kind of makes sense. If you repeat a thing 0 times, you should still probably get a string, but what's in that string? Well, nothing. There are no characters in it. You can actually ask for the length of strings. That's a function on strings, just like you'd expect it is. So if I say length of hello world, I'll get 5 plus 5 plus 1 for that space character in the middle, because yeah, that invisible space is also a character. So there's 11 characters here. That's that. And like I say, the empty string is nothing special. It's just either a pair of double quotes or a pair of single quotes is how you write it. And it's the string that has length 0. It has no characters in it. This comes up, sort of more times than you would think it comes up. What happens if I ask for 100 times the empty string? Well, I join 0 characters together 100 times, and I'll get the empty string. There's no surprises here. Is the length of the empty string 0? It is, because there's no characters in there. Is the empty string plus the empty string the empty string? It is. Is the empty string plus hello? Yes, that's hello. The empty string is both a left and a right identity on strings. It's just a normal string. It's a thing that you should be aware of. So you may have already noticed the loophole in this fancy scheme of ours. What if I want to write a string with a single quote in it? Well, Python allows strings with both single and double quotes, so I can do this, and that'll be okay. If I try to do this, right, then Python's going to see that as a string, and then it's going to see this other stuff as trailing garbage, and then it's going to see this as starting another string, and it's going to get very confused. So it's like, no, that T, I don't know what that T is. So I have to use double quotes around that. And if I want double quotes in my string, I have to use single quotes around it. And that works, but wait a minute. So what if I want to use both? What if I want to, if I want to use single quotes, I need double quotes. If I want to use double quotes, I need single quotes. What if I use both? I want a string that has both double quotes and single quotes in it. Well, we have what's called the escape convention using the backslash character. So if I say the word can't be orange, that backslash there says to Python, oh, whatever the next character is, why does this keep disappearing? Whatever the next character is, yeah, don't end the string with it. That's just a special character. So now it's like, oh, there's a T and H and E. Python gets there, it gets here. It's like, well, that's a single quote. That's fine because we're in a double quoted string. Oh, a backslash. Oh, and then a double quote. That means that's not the end of the string. That's a literal double quote. Some more characters. That's not the end of the string. It's a literal double quote, and so forth. So that's what's called an escape convention. And you'll notice that the backslashes disappear here when it's printed because I've got to get it to quit doing that. The backslashes disappear when it's printed because it's going to be because they serve their purpose. It let you type the string in the way it's supposed to be. And in fact, oh, I see. No, it disappeared because it went the other way around. So this is now a single quoted string like Python likes. So it backslashes this single quote and leaves the double quotes alone. Whatever. So that's the backslashing convention, but there's one last twist. What if I want to put a backslash in a string? If I write something like a backslash, but wait a minute, that backslash says treat the next thing specially, and I don't know what that's going to do here, right? What if I want to write backslash double quote? Well, okay, we have that case covered too. It turns out that // means a single / character. Treat the next character as a literal / character. So now we can write that, and it prints it the same way we saw it. But if I print this, print strips off all the quotation from your strings, and so it'll print it, it'll print it the literal text without any kind of quoting of any kind. And so in that situation, this string will print like that. All that's pretty complicated. Most of the time you're never going to have to care. You should just be aware that's a thing you can do. So, there's a whole bunch of special cases so that we can represent any text by typing an appropriate string into Python. The last topic is that we have these characters we call sometimes control characters because they don't actually print on the screen. Even the space character you can kind of think of as a character that prints on the screen, but a control character is sort of an action that does something. So for example, we have a character we call newline in Python. The newline character makes the text go to the next line, the beginning of the next line. And there again, to put new line characters in a string, we use a / convention. It turns out the thing / n is special and means a new line. So if I take a string like this, this is 3 lines of text, new line, second line, new line, third line. If I type that into Python, it will be perfectly happy with it. If I go to print it, what will happen is when it's stripping off the quotation and turning these things into what they're supposed to be, okay, that's going to drive me nuts really, really fast. Please stop. How do I get out of present mode? No, I want to get out of full screen mode. I see what's happened here. I hate presenting. Okay, there we go. So if I print this without the this is 3 lines of text. If I print this like this, it'll print this text, and then it'll go to the beginning of the next line, and then it'll print this, and then it'll go to the beginning of the next line, and it'll print this, and the net effect is that this comes out like this. So I can represent pretty fancy texts using the text processing apparatus here of Python strings. Strings are just a kind of value, just like numbers are a kind of value. And we'll be messing with strings a lot in this course, and so I thought it was important to at least get some of the basics down. There's so much more to be said here. We absolutely can get find out what characters are at specific positions in the string. We can absolutely take pieces of a string. We can do things like uppercase and lowercase characters in a string. But this is probably enough stuff to get you started working with strings, at least until we need more. So there you are. I hope that was helpful. I hope you're all staying safe and well in these difficult and interesting times. And I look forward to talking to you again real soon. Take care.